get you a copy of the notes. And if you'll remind me, I'll give you the key to the worksheet so you can check yours after we do this. Okay, so we're going to start talking about parallelograms today. All of you recognize parallelograms. I think most of you know the definition. It's just a quadrilateral with two pairs of parallel sides. That makes it a parallelogram. So in this diagram, since the top and the bottom are parallel and the left and the right sides are parallel, this is a parallelogram. And notice this little symbol that looks like a parallelogram. It's the symbol for parallelogram. Who'da thunk it? Okay, so you'll see that used all the time. It's especially nice because parallelogram's a long word. Okay, so now we're going to look at the properties of parallelograms. What things are true about parallelograms? Pardon? Well, that's in the definition. And please take the ear thing out. Nope. That's not allowed. Sorry. Yes. But yes, other than the sides being parallel, there's some other things that we can know. Let me show you. You don't need to copy this, but please watch. If I draw in a segment from, say, Q to S, that's called a diagonal. Okay? I've created two triangles. Well, the top and the bottom are parallel. These two alternate interior angles are congruent, right? And if the left and the right sides are parallel, then these two alternate interior angles are congruent. And this side is congruent to itself by the reflexive property. So what do we know about these two triangles? They're congruent, which means any of the matching pieces are congruent. That means that side QP is congruent to segment RS. And side QR is congruent to segment PS. And that angle P is congruent to angle R. So there's all kinds of stuff that we know. One thing that we know is that the opposite sides are going to be congruent to each other. Another thing we're going to know is that the opposite angles, the angles that are across the figure from each other, are going to be congruent also. So, first property, the opposite sides are congruent. And this is the one that I think is the most obvious. You look at it and you're like, yeah, it looks like it. Okay, it's right. In a parallelogram, the opposite sides are congruent. So if this is a parallelogram, then AB is congruent to CD, and AD is congruent to BC. Likewise, the opposite angles are congruent. If this is a parallelogram, then angle J is congruent to angle L, and angle M is congruent to angle K. Both of those things are true. Okay, I think that one's fairly obvious also. What kind of an angle does angle J appear to be? I'm sorry? It looks obtuse. Which other angle looks obtuse? L. Those two angles that look obtuse are indeed both obtuse and both congruent to each other. The two that appear to be acute are acute and are congruent to each other. So we've got that going for us as well. And again, I think it kind of looks like it, so it's not super hard to remember that one. Okay, let's go back up to this diagram here at the top for just a second. What kind of angles, we haven't done this in a long time, are angle Q and angle P? Yeah, same side interior angles. And when lines are parallel, what's true about same side interior angles? Nope. Nope, they're not a linear pair. They're supplementary. They do add up to 180, but they're not a linear pair. So that is our next. If you'll turn the page. The consecutive angles are supplementary. And that's just because they're same-side interior angles. So there's lots of pairs of those. V and R will be supplementary. V and T will be supplementary. R and S will be supplementary. And S and T will be supplementary. So you pick out two in a row, they're going to be supplementary. If you pick out ones that are opposite each other, what's going to be true about like angle T and angle R? They're going to be congruent if this is a parallelogram. The last property is that the diagonals bisect each other. If you draw in both diagonals, they're going to cut each other in half. Now, how do I know that? Well, let me show you real quickly. Again, you don't need to copy this part down, but do watch, please. I know these two sides are parallel, right? So that means this angle and this angle are congruent, because what kind of angles are those? Anybody? Alternate interior angles. And these two angles are congruent. And if this is a parallelogram, what do I know about the opposite sides? They're congruent. Exactly. Yeah, we could do the verticals. We don't need to. We have enough already. But yes, we could absolutely do the vertical angles congruent. How can I prove these two triangles congruent? Yeah, angle, side angle. And then any of the matching pieces are congruent. So AM and MC are congruent. And DM and MB are congruent. So those diagonals are going to cut each other in half because this triangle and this triangle are going to be congruent. So if you draw in either one or two diagonals in a parallelogram, you're going to get congruent triangles every single time. All right, so let's do some example problems. Starting here, find the measure of each angle in parallelogram COLD. Well, let's start with the easiest one, where we don't have to do any arithmetic. What angle do we instantly know without having to do any arithmetic at all? L is 68. And what about angle D? How'd you get that? And who got it? I'm sorry, I didn't see who said it. All right, so how do you know that it's 112? Yeah, these two angles are going to be supplementary. So 180 minus 68 gives us 112. Very nicely done. So that's 112. And then that's going to be 112. All right, let's take a look at this next example. WXYZ is a parallelogram. What a boring name for a parallelogram. Find each measure. We want to find the length of XY. All right. Well, XY is going to be the same length as what? 12A, WZ. Problem is I don't know what A is yet, do I? But
6A plus 10 equals 8A minus 1.
Exactly right. These two sides have to be congruent also. So I know that 6A plus 10 is equal to 8A minus 4. So that'll be 10 is equal to 2A minus 4. Add the 4. We get 14 is equal to 2A. So A is 7. And I know that this is 12 times A, because the opposite sides have to be the same length.
84.
So it's what?
84.
84, thank you. And somebody else tell me about these two angles. Yes, they are supplementary. So I just need to write an equation that says that. 18b minus 11 plus 9b plus 2 is 180. So that's 27b minus 9 is 180. Add the 9 to both sides, and we have 27b is 189. Now we need to divide both sides by 27. Dividing by 27 is difficult, yes? God bless you.
Are you allowed to use a calculator?
Not yet.
It's 7.
It's 7?
Yeah.
Okay. But other than doing, when you're doing long division, dividing by a 2-digit number is kind of icky, right? Can we make this better?
Divide everything by 9.
Okay. Are both of these divisible by 9?
Yes. 21.
And is that a pretty easy division to do?
Yes.
Yeah, do that. 9 into 189 is 21. And 9 into 27 is 3.
Oh, sure.
That didn't sound good. So then b is equal to 7. So if you can reduce the fraction rather than do an icky long division, do it. All right, so then the measure of angle y, well, oh, wait a minute. The measure of angle y, how am I going to find it? There are two different ways. One of them's faster than the other. Jonathan?
By the measure of angle W.
Yep. And that'll be the same as the measure of angle y, right? So that'll be 18 times 7 minus 11. Let's see, that's 70 plus 56 is 126 minus 11 is 115. Okay, any questions about that? Okay. One more example. Maybe it's just one more. Yep. So in this one, I'm giving you all kinds of stuff. Some of it is actually things that you don't need. Okay, they're called distractors. So let's see. I know that this is a parallelogram. That's important, otherwise I can't do anything with the problem. Then LM is 28. LN is 26. There's really not a good way to put that on the diagram, is there? Because of that, I'm going to circle it so that I don't forget it. And LK is 20. Let's go ahead and do the segments that they've asked for. They asked for the length of NK, or KN. What is the length of KN going to be? 28 inches. Then they ask for the length of LO. You're like, uh-oh. That has nothing to do with the 20, does it? But it does have to do with this. If this entire diagonal is 26, and the diagonals in a parallelogram bisect each other, that means they cut each other in half, how much is each piece? 13. So this is 13 inches. All right, I'm going to change colors. Let's see, LKN. LKN. This whole angle is 74. You can write it like over the whole thing. I tend to do this and say that whole angle is 74. To me, it gets less in the way of things. And then they also tell us that angle MNO, this angle is 62 degrees. All right, then they ask us for the measure of angle NML. NML. Oh, they just want this whole angle. How much is that going to be? 74. And then they ask for angle ONK. This angle right here. That one takes a little more thought. Remember that the opposite angles are congruent. What's true about the consecutive angles?
Supplementary.
They're supplementary. So if this is 74, take 180 minus 74, and that's 106. This whole angle is 106. So then from that, how can we find the measure of angle ONK? Yeah, take 106 minus 62. So this angle is 44 degrees. Okay, any questions? Okay, your assignment is in the book.